this is JD here. Today we are going to extend our understanding as far as the knowledge for calculus is concerned. Remember, so far we have introduced the module differential calculus. I've said in this chapter it's very important for you to understand the derivative of each and every type of a function that we have. Recently we've looked at polynomial functions, so today we're going to extend our understanding, taking a closer look at what we call exponential functions. So we have a problem that I've posed here on the board. Given that theta is equivalent to e to the power of sine x, find d theta dx. How are we going to differentiate an exponential function? To do this, this is very simple, straightforward, and quite interesting. Right, so you need to bear in mind that if y is equivalent to e to the power of f of x, for you to find dy dx, or what you need to do, you just need to differentiate the power, which is the derivative of f of x. So once you find the derivative of this power, then you multiply by that function again, which is e to the power of f of x. So in this case, therefore, in this case, we've got theta is equivalent to e to the power of sine x. Right? So for us to calculate d theta dx, or what we have to do, we need to find the derivative of the power. So we have to find the derivative of sine x, and once we have the derivative of sine x, then we multiply by e to the power of sine x. So in this case, the derivative of sine x, straight away it gives us the cosine of x times e to the power of sine x. That's it. That's all what you need to do when it comes to differentiating exponential function. Simply have to differentiate the power. After differentiating the power, then you multiply by that function, as you see in this example. Awesome. Okay.